Cool. All right, you ready to go?
Ready to go.
Excellent. Make sure that we are recording. We are recording. Here we go. Hello, and welcome to episode 59 of Great Things with Great Tech, the podcast highlighting companies doing great things with great technology. My name is Anthony Spiteri, and in this episode, we're talking to a company focusing on cloud optimization via a platform that reduces cost, optimizes DevOps, and automates disaster recovery. They achieve this with an intelligent optimization engine, delivering cost-efficient, high-performing, and resilient infrastructure for every Kubernetes workload. That company is CAST AI, and I'm talking to Leon Cooperman, CTO at CAST AI. Welcome to the show, Leon.
Anthony, how are you, sir?
Excellent today, and looking forward to talking about something that is, well, two things that are really hot in today's world, that is Kubernetes and AI. But before that, I just want to give a bit of a shout out to the show. So if you do love Great Things with Great Tech and would like to feature in future episodes, you can click on the link in the show notes or go to GTwGT to register your interest. Just as a reminder, all episodes of GTwGT are on all good podcasting platforms, Google, Apple, Spotify, all hosted and distributed by Anchor.fm. And as a reminder, on the YouTube channel at GTwGT Podcast, go there and subscribe. So with that, let's talk about CAST AI. And I guess the first thing to talk about, Leon, is your background and the founding of the company, because I think it solves a really interesting problem that a lot of people are facing and going to face today. But first, let's go back to your background, because it's really interesting as a serial startup guy. So give us some information about how you came to found CAST AI.
Yeah, well, we can go back really far, but so I'm a software engineer by trade. My first and only big company job was when I left university. I worked for IBM. So I worked on this cool product called WebSphere Commerce Suite. Back then it was IBM's introduction into e-commerce.
Okay.
So one of the early developers. And then I kind of very early realized that, so Anthony, it's kind of, if you live in a family of entrepreneurs, that tug is very strong. So as immigrants to North America, my parents were not entrepreneurs, my brother's an entrepreneur, family business, and I had that pull to get into a business of my own. And so the kind of inkling I had there was, well, it takes a year and a half to ship this shrink wrap product for IBM. Why can't we just offer it to people as a service?
Yeah.
This is kind of before as a service existed. And so that was kind of my journey into startup life. And since then, I've only really been at one other big company at Oracle, and that was due to an acquisition, which was a lot of fun.
Okay.
But everything in between was focused around my software engineering skills as a technology leader and also as an engineer, but in that startup arena.
So in terms of the space that you were focusing on, was it more security focused? Has it always been around that security, or has it been varied in terms of the previous companies leading up to CAST AI?
That's really interesting. So no, I didn't start out as a security focus. In 1996, I started out as having a specialization in e-commerce. How do you bring product online? How do you sell it? How do you do payment processing? And then I was attacked in one of these startups, and it was a ransomware. Before there was Bitcoin, you used to get ransom notes saying Western Union $5,000.
Oh, that's really old school, isn't it? There you go.
Really
that's old school ransomware, yeah.
And so it was a DDoS attack that was affecting our business, and I had all these vendors that I thought were going to protect me. And the technology for protection was still very immature. And what I found was ultimately we're pretty naked. Like we didn't know what the skill set and the technology we needed to really adequately defend our business. I ended up paying the ransom finally after a week of struggling.
Oh, okay, yep. There you go.
And I got this interesting email back from the attacker. He's like, well, you've been such a good customer. Give us a couple of competitor names and we'll attack them free of charge. And I'm like, this is like a whole, obviously I didn't give him any competitor names.
Yeah.
But that's what led us to the idea of ZenEdge. ZenEdge was a founding, which was the first cyber security company that I was involved in. Like, we need to figure out how to protect customers that don't have any expertise in this field and extend that to web application security in general.
Okay.
And so that kind of started my cybersecurity career, right? But it was a pain point from solving a previous problem.
That's interesting. And then, as I understand, CAST AI, born out of another problem that you had at that company, which was spiraling costs of cloud. So just want to explain how, number one, how that problem influenced the creation of this next company.
Yeah, so when we were building ZenEdge, like really good product, I think analysts and customers and the whole ecosystem really liked it. Very easy to use compared to some of the legacy stalwarts in the market. But we had one problem. We launched the company in AWS, in all regions in AWS. It was a reverse proxy. So essentially we would proxy all traffic
Okay.
and pay AWS for the egress, but also the compute to do all of the threat analysis in real time. And so every time we signed a large customer, our bill would kind of jump. Like so our gross margin was suffering. And with software as a service valuations, as you know, Anthony, gross margin is extremely important.
Yeah.
So I would have this constant, every month the bill would come in from AWS, and we would have this constant debate with the finance team and my CEO, like, why is this growing out of control? Like I'm trying to add profit to the bottom line.
Yeah.
The cost kind of went away because it was hidden under the platform.
Yeah.
So we never really solved it, and then it was bothering me all through, all through the time we went through that transition. It was nagging at me as an unsolved problem, and I can't be the only CTO in the world that is having this significant challenge with cost and budgeting.
Absolutely.
And then at the beginning of the pandemic, we had this chip shortage. And this is when it really hit home, when all of the cloud providers were really struggling to provide capacity.
Yeah.
And everyone was being asked to do manual efficiency projects to bring down the number of CPUs that they're committing to from the cloud.
Yeah.
It was all manual. And I'm like, wow, this is a global scale problem that we can impact with some critical thinking and intelligence. And that's how the company was born.
Yeah, that's really interesting, right? Because it's been a problem in the cloud space, public cloud space specifically for the longest time. And in fact, if you take it back a few years, I mean, like you know, and like I say in a lot of episodes, like working for a service provider in the past, we would sell an allocation pool to customers. And that allocation pool was a best guess effectively as to what they thought their total burstable resource would be. Now, we loved it because 99 times out of 100, they were over provisioning for what they really needed. And obviously the way that you make money in that sense is via over provisioning under consumption, right? So we love that fact, but it just exposed the idea that people don't really know what they need. And then you've got the problem of moving from the physical world to the virtualization world to the containerization world, which fundamentally it's still all about compute and resources and the consumption there. But all of a sudden you haven't just got one IT guy doing the allocation. You've now got different teams. You've got developers, you've got IT ops people, you've got SRE teams. So you've got all these people that are putting in their 2 cents worth in terms of what they think the resources should be. So it's a nightmare, right? Let alone when it goes up to the C levels to actually get someone to explain why the cost has blown out so much.
Yeah, and if you've ever seen like a bill from one of these cloud providers, you literally have to be like a PhD in economics to understand like the thousands of line items on a simple bill, never mind a complex organization.
Yeah, that's kind of like part of the trick of the trade, isn't it? Like just make it as complex as possible so it looks like it's just too hard to actually go through and actually work out what we may or may not need.
Yeah, and I think AWS particularly suffers from this, and then all of the other clouds have kind of taken this on. They feel the need to charge on multiple dimensions. So you're getting charged for the compute cost, you're getting charged for the egress, the ingress, the load balancer. Like there's like 10 things that make up this one line item, and it's very difficult to understand at the end, right?
Absolutely. So I guess we haven't really talked about CAST AI as such just yet, right? We've talked about the problems, your history. So talk a little bit about CAST AI, what you guys do in light of what we've just talked about.
Yeah, so we started with this kind of thesis assumption. the world will eventually move to containerization. And if that's true, then we need an orchestration strategy that makes sense, right? And there's two narratives around orchestration. The cloud provider, because they always want to be up the value chain, will say, we'll just give you containers as a service like Fargate or container instance provider, and don't worry about the control plane, don't worry about all of the management, we'll just take care of it for you, right? Well, that comes at a very significant price, and price of dollars and control.
Yeah.
And then the other kind of open source vision of that is, well, we have infrastructure as a service. The orchestration platform is clearly, the winning orchestration platform is clearly Kubernetes. So Kubernetes, for those folks that don't know, is a container orchestration platform that allows you to run many containers in various configurations across a cluster of computers. And it came from Google. Ironically enough, it was called Borg inside of the Google SRE team.
I didn't know that. Feels like something I should know, but I didn't.
Yeah, and so when they open sourced it, they changed it to Kubernetes, which is a Greek word for navigator. So that's why Docker is. All of these are nautical themed.
It's all linked together in some sort of, let's take a bit of a hit at the competition sort of way. Yeah.
Yeah. So if you assume those two things, right, and I'm a strong believer that kind of all things will converge to containers and some flavor of Kubernetes in the near and medium and long term, then this platform is really hard. If you've ever run Kubernetes, or if you've ever done tutorial, there's a really nice tutorial called Kubernetes the Hard Way. If you ever want to go through the steps of setting it up yourself.
Okay, we'll link that. I'll link it in the show notes.
Yeah, it's very difficult to run as an SRE and even as an application owner. So we have this principle that we have too few people in the industry. On the managed service provider side, on the SRE side, on the dev side, we need to figure out how to get them out of doing this low-level grunt work on these cloud platforms and elevate them to, it's not about replacing them and not having a DevOps person. No, It's about elevating them to do more creative work at the platform level and let the mundane stuff happen and be optimized by the machine or by the computer, because that's what computers are really good at.
Yeah.
So we came up with this concept of autonomous Kubernetes that solves kind of what we call day two operations problems in multiple verticals. And the first vertical we tackled was cost, because it was near and dear to our heart. And it's a major industry problem today, going into potentially what looks like a recession.
Yeah, absolutely. And I think, I mean, I've been to a few AWS reInvents, and obviously even back when my first one was in 2017, and I was just blown away with the amount of cost of companies that were literally related to cost, right? And how do we reduce the cost? And I feel like in the 6 years since then, we've come a long way in the underlying tech that can actually enable that. We've obviously seen a consolidation of sorts of those companies as well. The good ones have stuck around. And then you guys come in and, like from what I can tell, be very successful in a space that was quite sort of busy and quite full of other companies. So what made you guys stand out initially? Like what's the success behind CAST AI at the moment?
So there's a couple of pillars to the way we approach the market, both top down and bottom up. But if I had to boil it down, all of what I'll call from the 2017 era, like all of the cost optimization focused companies, were all about how do we consume the AWS build, make it understandable to financial teams, and then provide some recommendations to improve the situation. The problem with recommendations is no one will take them, because if it's not built into your standard operating procedure, if you're not exercising that muscle all the time, you're scared to exercise it. Like, what if I reduce these resources and it breaks my application? Mm-hmm. What happens then? So there's a bit of analysis paralysis. You see some savings on the table, but you don't actually ever execute it. And so those platforms don't actually live up to their full potential. We approached it a different way. We said, look, people aren't going to read reports. Maybe they'll read some reports for some results, but what we have to start was an optimization first strategy. So how do we take the quote unquote recommendations that our engine is producing and just remediate immediately? Okay. And if we're going to do that, what's the resolution of remediation? And we got to this extremely fast resolution of 15 seconds. Okay. We remediate our customers' clusters on a 15-second cycle to get them the best possible cost and performance for their apps.
And how's that achieved? Like, I know looking at the research I did into your company, you kind of, number one, you've got like a free sort of tier, which installs an agent of sorts or some sort of something on the computer or the Kubernetes cluster. It then creates a report, okay? And that's free. And then I think the next steps that the customers can do is then, actually get you guys to do the optimization, and you do that by replacing the inbuilt Kubernetes load balancer. So you guys are effectively replacing that function within a Kubernetes cluster.
Yeah, we replaced not so much the load balancer, it's the autoscaler. So
The
there's some,
autoscaler, okay, yeah.
yeah, the cluster autoscaler. So on Amazon, these are called autoscaling groups, and on other platforms, they're called scaling sets. But essentially, Kubernetes under the covers is broken down into these things called node pools, right? So groups of computers, and these groups of computers are homogeneous. They're the same computer over and over again. But when you're solving a Tetris puzzle or a jigsaw puzzle, you don't use the same size piece to solve the puzzle. Like, that would be, that's a material handling problem. So what we do is we use the right computer for the workload, and we find out of all Amazon has something like 544 SKUs available in EC2.
Yeah.
So, and they're available on demand with reserved instances as well as with spot instances. So there's some combination, some very high exponential number of combination of those computers and life cycles that makes the most sense for your app. And that's a very computationally expensive problem to solve, right? It's an expensive graph problem, but also the humans just can't do it. They just can't keep up with the rate of change. So that's where so there's kind of like 4 or 5 vectors of optimization, but in a nutshell, we're trying to match what the market clearing price is of that compute resource with what the customer needs today, without worrying about what they need in 6 months, because nobody knows.
Yeah, you've hit a good point earlier when you talked about cost efficiencies in times of financial stress, which is, what all roads lead to some sort of quick, sharp, vicious recession this year, right? And if you can provide cost savings on any level, that's going to be attractive to any organization, especially at scale. Like, obviously, if you've got a couple of worker nodes, you can get away with it. But if all of a sudden your application and these node pools that you got, we're talking thousands and thousands, that's going to add up. So, even saving 2 or 3% on an instance in AWS, like, I guess is what you're kind of working towards. If you times that by 1,000, that's quite a big saving per month, right? So in understanding that, is it just a case of how does the mechanics work with regards to how do you get the machine? I guess you're sort of using, obviously, AI, because it's in your name. So how do you get that pool of understanding as to what a particular application running on a particular node set or node pool is doing, and how you then make the decision to go, oh, let's now change this instance from a whatever to a whatever?
Yeah, so the agent that we install collects a whole bunch of information every 15 seconds, and then we report the delta or the change in position or state back to our data analysis platform every 15 seconds. So what kind of data do we collect? All of the pods you're running, all of the nodes they're running on. We understand the cost of those life cycles and the cost of those nodes. We understand the node's capabilities.
Yep.
We also understand what the pod is asking for and what the pod is actually using. Okay. So there's like always a discrepancy between those, right? And so we take and then there is another vector that is interesting, is that customers have these things called HPAs. If you're not familiar with an HPA, it stands for horizontal pod autoscaler. So what does that mean? When you're scaling an application in drastic sets, right? Like, I'm going from 1,000 requests per second to 10 requests per second. There's a couple ways you can do that. You can give a single pod a lot more CPU and memory, but often there's a cap. Like, if you have a single threaded process, for example, you just can't use more than CPUs than one, right? And the other way you do it is you create replicas. You create many, many, many copies of Nginx or of your web app. And when you create those replicas, you do those through an HPA. So you have this kind of harmonica feeling HPA application. So as those things scale up and down, they're actually creating waste on the way up, and they're creating waste on the way down. And so those are a couple of vectors that we're very heavily optimizing the focus on heavy and cost-effective scale down, which is at least a 10 to 20% difference
Wow.
between what is
Okay.
traditional.
Yeah.
And then as you're scaling up, making sure you're using the right type of computers for the job at the lowest possible price.
Right. Okay. So you're right sizing on the fly. It's dynamic right sizing, as I kind of understand it, through learned best practice through your customer base. So I think it's genius that you've got the agent sitting there getting this information, and then through effectively crowdsourcing it. You're understanding exactly what this pod's doing, what it should have, and how to actually optimize it. So I think it's brilliant from an optimization point of view. I've seen the term sandbagging sort of thrown around when it comes to resource optimization. What does that actually mean when people are sandbagging? I guess we've touched on it potentially, but what is it from your point of view?
So Andy, imagine you're an engineer and you're building some app, right? And then you say, okay, I had to deploy this app, and how many resources should I ask for this app? Well, what do? You kind of put your finger in the air and you say, oh, I need 2 CPUs. Just to be safe, let's give it 4, right? And
Yeah.
this much memory. And then let's say that gets done through your deployment CI/CD pipeline, and then your SRE team says and looks at it and says, well, we don't want to get woken up in the middle of the night, so let's just add maybe 20, 30, 40% more capacity. And that goes up the chain, and the more layers you have managing an application, the fatter that buffer or that headroom becomes. And then before you know it, the thing that only needs 1 is being allocated 6. And now you replicate that at scale, and you have a bunch of computers sitting idle that have allocated capacity, but they're not using it. And that's basically the sandbagging term.
And that then lends itself to, I think, one of the fundamental problems, which I believe you guys are trying to solve, which is this getting rid of the waste, effectively making data centers more efficient, energy usage, that sort of thing. It's an important, I think, as we move forward, with regards to computing in general, it's just going to become more and more important to be more and more efficient in what we use and don't waste. And you touched on the chips shortage early on. That created, pressure. I remember, was it Azure ran out of compute in England from memory last year. That could happen, right? So if everyone is sandbagging, then the potential is that it becomes a finite resource, which is actually the opposite of what cloud should be. But if we don't manage it carefully from the consumer's point of view, because obviously as a cloud provider, you try and add scalability, you try and guess which way your customers are going, and you add scale. But if everyone is basically taking it as much as they need, then wastage is going to happen. I kind of thought of an analogy there, same way that IP4 space got used up real quick, right? Because everyone just went, yeah, I'll take a C, no worries, no one's going to need that. And all of a sudden, it's like, well, we actually might need a bit of that back. So that's a bit of an interesting sort of analogy that I thought about in my head with regards to sandbagging.
Yeah, and if you look at IPv4 space and the cost, it's just escalating. And for whatever reason, people are not adopting IPv6 widely. And
They're not,
right?
Crazy.
So, but just to go back to that way, like when you have this waste built into the standard operating procedure of your business, essentially, you're not just affecting your bill. You're affecting, as you said, Anthony, the resource, like other people can't use those resources, right? Because the cloud is trying to be true to what they say you're allocated. But you're generating, those CPUs are cycling whether you're using them or not. So they're generating heat, they have to be cooled. They're using power. That power has to be paid for and generated. It can be clean or dirty, but as we know, electricity is more dirty than we want to admit.
Mm-hmm.
So you're not just wasting money, you're actually slowly contributing to the killing of the planet. And that's what we're really passionate about, reducing this footprints, because if we can get people just to use the compute they need efficiently, we imagine if we're saving 30-40% on a bill, we're also saving 30-40% on the power consumption and the cooling requirements of every data center.
And I've never really thought of it in that way, right? I've never thought of, my potential footprint that I use when I provision a server or provision a service, where it might be. But You're right, and I think we do have to start to think that way. I think a lot of people are, but I don't think a lot of companies at your level are actually, contributing to making that better and being outwardly positive about it as well. So I think that's a kudos to you guys, and definitely a feather in your cap as well.
Yeah, thank you. It's important to us that we create sustainable environments, and efficiency is just one leg of that.
Yeah.
And as I mentioned, this concept of autonomous platform is, we're just tackling the kind of the tip of the spear, if you will. But there are many other day two operations that need to be tackled. Security was one that we talked
I was
about
going to
earlier.
ask about security actually, like, how are you guys, because a lot of the headlines that I see with you guys is around security. So how are you guys contributing to Kubernetes and making it more secure?
So I think cloud security has generally come a long way over the last 5 years. Like there's a lot, there's a CIS benchmark that kind of allows you to understand your posture. There's a lot of policy as code that's been introduced into the various service providers. But once you get into Kubernetes, it's kind of like, oh, that's a completely different black box. And we don't know what's actually going on there from a security perspective. A
Yeah.
lot of the anomaly detection, it doesn't go into those black boxes. Containers are fraught with vulnerabilities, as you know, Anthony, because you're just building an operating system under the covers. So we found that the maturity level of K8s users is actually much lower than the cloud. Like if you look at IT as the superset, and then the cloud below that is slightly less mature, but getting there. And then K8s really needs to step up its maturity level. So we think that the continuously securing a Kubernetes cluster is not easy. And we want to help customers understand what vulnerabilities do they need to address now as security debt? What can wait a little bit? Like where are they in the remediation funnel essentially? That's kind of the angle that we're approaching it at.
Yeah, right. So as part of that initial, setup that you guys do, is it optimization and security in the one report that you do, or can users pick and choose when they install it, or is it just all in one? And then it's like, okay, well, let's see how we're going in the optimization. Let's see how we're going in the security. They can take the report as is and just kind of do what they want with it, or they can do like we talked about that next step. So from a security point of view, how do you guys handle the remediation around that?
That's a great, the remediation part's a good question, and we don't have an answer for it right now, but I'll tell you where we're going. So right now we have so much stuff that we give away for free. I don't know if I can like keep it that free and open but I'm going to try. So
Yeah.
when you install that agent, you get all of the cost reporting capabilities. So like imagine something like a cube cost that you have to install on your own cluster, which is open source. You kind of get that out of the box with the agent.
Okay.
And then you also get all of the recommendations for how to size your cluster properly at no cost. And then you don't have to host anything. You get this ongoing kind of report that shows you your progress,
Okay.
even without automation. But you also get a security report, and that security report tells you what best practices you're violating, and and then how to remediate them, and then all of your container vulnerabilities. So in the containers that you've built, what layers are you using, where the patches are required, and what package you're using in your app that actually have vulnerabilities in them. And then you can go remediate them based on known fixes.
Right. Okay. Cool. So and I guess in general, like we talked about the black box of Kubernetes to most people, and my experience is that there's not a lot of really. I mean, obviously there's a lot more people today versus maybe 5 years ago that are a lot more au fait with the building blocks of Kubernetes and not just the black box. But a lot of people that interface with a Kubernetes platform, typically your developers and those SRE types, they don't really care as much. It's not their fault, I mean, they're doing what they're doing. They want to build an application. They want to put it somewhere that works. They want to make sure that it actually does its thing. So you're saying that from the point of view of the guys that are operating the platform, so the platform ops guys, you're giving them a great report to be able to go and remediate and make sure that they're going to be, running the most sort of security focused Kubernetes platform that they can do.
Yeah, and then the remediation, like there's some traditional strains that you go into remediation. So there's something called the SOAR platform, security orchestration, right? Like what do you do when you find a problem? Like companies typically have pipelines to fix those problems. It could be a Jira ticket, or it could be something more sophisticated. What I'm really interested in exploring, Anthony, is the GitOps approach. In other words, if I know that you have to kind of patch a container version. Can I submit a pull request to your repository with the fix, have one of your engineers review it, apply it to the pipeline, and then remediate it that way? Because what's the point of me fixing an image in your cluster if it's going to get overwritten by the CI/CD platform anyway?
Yeah.
We have to shift, what the term is called shift left,
Yes.
meaning get to the source of the problem. And I want to do that through GitOps.
Yeah, interesting, because I take that approach from a backup perspective in a way, right? Like if your application has changed, all of a sudden, and you want to insert into that pipeline the ability to back it up on a change and have that then fed back into the CI/CD. There's all that sort of way of looking at it. So I think I understand what you're talking about, and I think it's going to be pretty successful. With regards to you mentioned you don't need to host anything. There's no infrastructure as sorts, right? So you guys have got your SaaS platform, you've got the agent, and that's the only thing that people need to install, basically.
Yeah, there's like 3 Helm charts. So there's an agent. When you go to automation, there's a cluster controller, a spot handler, and something called an evictor, which is our bin packing. And it bin packs within the clusters. There are like 4 components.
Okay.
And then there's a couple of security agents. So there's one security agent that detects your traffic anomalies. There's another security agent that does image scanning within your cluster. So there's a couple of things, but we orchestrate that as an operator and just deal with it for you. You don't have to worry about it.
All right, good stuff. So I think I want to kind of finish off talking about the AI component, right? Because obviously it's pretty prominent in your name. So before we get into the state of it, it's again very topical for where we're at in the IT world at the moment with regards to AI, and we'll touch on that just to finish off. But how did AI find its way into the company? Because obviously it's very prominent, CAST AI. So explain, because I think there's an element of risk in that. And I say that from the point of view of there's lots of people claiming that they're doing AI today, right? So how have you guys been able to be bold enough to put it into the name, but also deliver on it as well?
Yeah. So there are some problems that can be solved with simple heuristics, and our methodology is if we can solve a problem with a traditional algorithm, we will. There's some problems that require prediction. So prediction of a future state, and those is where machine learning algorithm. And so out of the whole field of AI, we don't deal with natural language processing. Where we deal with prediction problems. And those prediction problems are usually time series problems, meaning, like, for example, we've got a market clearing price of a particular computer. What will that market clearing price look like in an hour or in a day, right? So we have to take those factors into consideration. When a spot instance gets interrupted, can we give ourselves, we only have 2 minutes warning on AWS, 30 seconds on Google. Can we give ourselves more notice? Can we predict spikes in a workload so that we can be ready for those spikes versus being reactive? So those are some of the problems that we have to use machine learning to solve.
Yeah.
And then other problems where we don't have to use machine learning to solve. And we're very pragmatic about which algorithm or model goes where.
Yeah, and that's a great answer, Rob, because I think that separates, from what the hype is today around, the NLP stuff, which is obviously making all the news today with ChatGPT. And like this week, there was Bard, and then there was Bing and Edge search chat that got sort of announced today from Microsoft. So what's your theory on that in terms of where that industry is today? How mature it is and where it's going? Because I've done a couple of sort of other podcasts around this and talked about the fact that it's exciting and scary all in the same sort of sentence and breath. So where do you see it going? How's it going to make our world better?
So it is exciting. What's interesting, just to point out, is the model that OpenAI is using and they've trained on is this thing called it's a neural network transformer. Google invented it years ago, like a few years before OpenAI. They just implemented it. I think Google was just caught on its heels a little bit from implementing it, and they were in the perfect position to kind of train on the vast majority of the internet. They just didn't.
Of course,
right?
Interesting. Yeah.
So it's not like they have OpenAI as some technological advantage that isn't in open source. That's why you're going to see a lot of these copies. I think the biggest problem happens not necessarily with when you get to commercialized usage of these kind of natural language processors, and these things that are breaking what's called the Turing test, essentially, you don't know if you're talking to a human or a
Yep.
robot, is how do you attribute back the input source of, like, when you learned a piece of source, like, so we've played with this, right? How do we generate source code to solve a computer science problem? Well, that came from GitHub somewhere. It came from somebody's, snippet. It learned on some features that were in public domain. But if you don't attribute the credit back to the author, I think there's going to be a significant legal question that has to be answered first. So that's kind of my 2 cents on, before we can broadly commercialize, we have to battle that part out and get an understanding.
I didn't, I mean, obviously I've been using it, ChatGPT, since it came out, and Mind Journey and all that kind of stuff, but I never thought about what you just mentioned, which is it's been fed this information from something that's real and tangible and that someone created. Like, humans created all the points that it got fed to be able to give its varied responses to whatever you throw at it. So does the fact that it's so fragmented from all of these resource points mean that it's not someone's work? That's really interesting.
Yeah, and because it's a neural network, it's highly unexplainable. You can't go into the black box. And the reason why search engines worked is because you would click on a link and you would see the source of the data, right? It wasn't owned by Google in that case.
Yeah.
In this case, it's opaque. So that's kind of the conundrum right now.
That's really interesting, and I don't think I've ever heard that particular sort of thread brought up in this era that we're in. So, yeah, I wonder what they're going to do, because you're right. I mean, ChatGPT introduced a $42 paid instance for if it runs out, and if capacity reaches a certain level, you can always get access to it. So they're already at levels of commercialization. I think the Bing one today, there was some sort of upsell that Microsoft was trying to bring into it. So yeah, it's like they're cashing in straight away, and like we started with, which is a good sort of way to round it out. That in itself is cost blowout, right? And people are going to start to go, oh, I can spend $5 on this iPhone app that gives me a good avatar. Guilty as charged here, right? Just spending the money just to see what it's about. But we did it. But that then leads to wastage as well. Compute, storage, everything that we've talked about. So to come full circle, it's interesting in terms of what this added stress on the compute networks that we have will do to the world.
Yeah, and it's the machine learning apps are a little bit worse because you often use these GPU optimized computers, which are very expensive, especially for training, right? So like OpenAI has so many millions of cores that they're using to train. It's a very interesting problem.
No, excellent. Well, hey, this has been a really good conversation. I'm sure we could have talked about that particular thing for an hour and a half as well, but we've almost reached the end. I just wanted to let you guys know that obviously I'm going to post a lot about what CAST AI are doing. We'll post to some of the web materials. You've got some great resources online, great learning around Kubernetes in general. I think that you guys are doing a really good job. I love the ethos of the company, how it started, and what you're looking to do. So, I really thank you, Leon, for being on the show. And just as a final reminder, again, if you like great things with great tech, please head to GTwGT.com. Go to the website, go to YouTube, click the link, and like and subscribe. Leon, thank you very much for being on, and we'll catch you next time on Great Things with Great Tech.
Thank you so much, Anthony. Great to talk to you.